Plane angle and solid angle have option A, dimensions but not units, no units and no dimensions, both units and dimensions, and option D is units but no dimensions. Now always remember, plane angle is measured in radians. So plane angle has a unit of radians, and solid angle, which is in 3D, it has a unit of steradian. So both of them have units, but do they have dimensions? No. So correct answer for this one is option D, units but no dimensions. The angle of 1 minute of arc in radians is nearly equal to which of the following options? Now 1 minute, we know that 1 minute, let me write here, 1 minute is equals to how much? 1 upon 60 degree. Okay. In case if you remember the other way, 1 degree, okay, that is equals to how much? 60 minutes, right? So 60 minute. So 1 minute will be how much? 1 by 60 degree, correct? And 1 minute is equals to 1 by 60 degree. If you want to convert it into radians, what you have to do? You have to multiply it with pi by 180, right? So 1 by 60 into pi by 180. Since 1 degree multiplied with pi by 180 will convert this whole thing into radians, right? So 1 degree has how many radians? Pi by 180. So 1 by 60th part of a degree will have how many radians? Pi into pi by 180. And when you solve this, you will get approximately 2.91 into 10 to the power minus 4 radians. So correct answer is option A. What is the unit of thermal conductivity? So out of these four options, we have to find the unit of thermal conductivity. Before we go to this finding the unit, let me remind you that what is thermal conductivity. So first of all, let's recall our relation for rate of heat flow. So rate of heat flow dq by dt is nothing but Ka times delta T upon L. Correct? What is rate of heat flow? Dq by dt, and dq by dt is in terms of joules per second, right? What is K? Thermal conductivity. A, area. Delta T, temperature difference. L, length. Correct? So K is the coefficient of thermal conductivity. So we can take K as simply that is equals to our L upon A delta T into dq by dt. Correct? This will be our what? K. K is our thermal conductivity from class 11th. Which chapter? Thermal properties of matter, right? Now let's put the units. L is the length of the rod or length of that object through which the heat is flowing. So that will be in meters. Area, meter square. Area is meter square. Delta T, temperature. What's the standard unit of temperature? Kelvin. And delta Q, dq by dt is rate of flow of heat, which is how much? Watt. Okay, joules per second is nothing but watt. So now we can cancel out meter with one of the meters, and our final unit will be watt meter. 1 meter will be left in the denominator, so meter inverse and Kelvin inverse. So let's see which one is the option. Option C here is the correct answer. The damping force on an oscillator is directly proportional to the velocity. The units of the constant of proportionality are, so first of all, we know that damping force F is directly proportional to velocity, right? More will be the velocity, more will be the damping force. So if you remove the constant, it will be, remove this proportionality sign, you will get a constant kV. And this constant of proportionality will be the ratio of force upon velocity. And what's the unit of force? Unit of force is Newton, and velocity is meter per second. Correct? Newton upon meter per second. What is Newton? Newton is nothing but mass times acceleration, which is kg meter per second square into meter per second. So let's cancel out here. This meter will cancel out with this meter. Let me rewrite this velocity properly here. So meter cancels with meter, and second and 1 of the second will cancel out, and you left with kg second inverse. So correct option is option C, kg second inverse. the density of a material in CGS system of units is 4 gram per centimeter cube. In a system of units in which the unit of length is 10 centimeter and unit of mass is 100 grams, the value of density of the material will be how much? Clear? So in CGS system, here we have the density. How much? Let me write. The given density is 4 gram per centimeter cube. Correct? Okay. Now they are saying that the system of units which we will have to adopt is having length as 10 centimeter and unit of mass is 100 grams. Correct? So what we will do? Now we will convert it into our this new unit system. So this will be how much? This will be our, we can do it as density will be equals to 4 into 100 upon 100 whole divided by 10 upon 10. Correct? Whole cube, because it's a centimeter cube. So this will be giving us 4 by 100 whole divided by 1 by 10 whole cube into 100 divided by 10 cube. Now why we did 100 upon 100? We're rationalizing simply 10 by 10. Correct? Because 100 upon 100 is 1 and 10 upon 10 whole cube will be 1. We didn't change it. Right? Now this will give us 100 grams and this is our now centimeter 10 cube centimeter cube. Correct? So 4 upon 100, that will be how much? Or let me just rewrite this expression as 4 upon 100 whole divided by 1 upon 1000, and 1000 goes up. Okay, and that will give us an into 100 grams upon 10 cube centimeter cube. Right? So this will give us 40 units in this new system. Clear it is? So let me repeat the whole scenario. Our density here is 4 gram per centimeter cube. Initially, we are changing the CGS system into the new system. In the new system, length is 10 centimeter, one unit is 10 centimeter, and unit of mass is 100 gram. So I rationalized it with 100 grams up and down. And since centimeter is in denominator, so we rationalize it with the 10 with the, because 10 it is given in the question here, 10 centimeter. So up and down we rationalized it. Now I separated the given unit, which is as per the question, and the remaining term will be our new value of density in the new unit system, because this is our new unit. Clear it is? Unit of permittivity of free space, epsilon naught, is how much? So 4 options are given. Let me remind you. From Coulomb's law, F is equals to how much? 1 by 4 pi epsilon naught Q1 Q2 upon R square. Right? So epsilon naught is nothing but Q1 Q2 upon 4 pi R square into F. Now what's the unit of Q? Coulombs. So Coulombs square whole divided by, now 4 pi doesn't have any unit, it is a constant. R is meter square into Newton. So Coulomb square per Newton meter square. So correct answer for this must be, let me check here, Coulomb square per Newton meter square. I think there should not be a bracket over here. So it should be, so the correct answer is Coulomb square per Newton meter square. None of these is the correct answer. Okay, there must be Newton meter square. There, this bracket should not be there, the whole bracket. Clear? Value of Planck's constant in SI unit is 10 to the power minus 31. No, all of them have same magnitude, 6.63, 6.63, 6.63, 6.63. So we have to focus on the power. So raised to power minus 31, minus 30, minus 32, minus 34 is the correct answer. 6.63 into 10 raised to minus 34 joule second. The unit of Stefan Boltzmann constant is how much? So first of all, we should know what is our relation for Stefan Boltzmann. Okay. So relation for Stefan Boltzmann law, we can say is E, the energy radiated per time, is equals to sigma A T to the power 4. Again, which chapter? Class 11th. Okay. This is from thermal properties of matter. Correct? So sigma will be nothing but energy radiated per unit time. Okay. Okay. and take this a and t to the power 4 on the left hand side. It will be a t to the power 4. Be very careful. This t is time, this is temperature. So energy radiated per unit time, that is watt, okay, power you can say, whole divided by meter square, and temperature is Kelvin square. So Kelvin, sorry, to the power 4. So watt upon meter square Kelvin to the power 4, which is option A. In a particular system, the unit, there is a small mistake here. So this is our unit of length, mass and time are chosen to be 10 centimeter, 10 gram, 0.1 second respectively. The unit of force in this system will be equivalent to how much? Again, I am repeating the question. In a particular system, the unit of length, mass and time are chosen to be 10 centimeter, 10 gram and 0.1 second respectively. The unit of force in this system will be how much? So first of all, we know that force is nothing but our Newton. Newton is a unit of force, okay? And what is the dimension? Dimension is m1, l1, t minus 2, correct? And mass is how much? 10 grams. Length is 10 centimeter and the time is 0.1 second, right? So what we will do here, we will convert it into that system. So 1 Newton is nothing but kg meter per second square, correct? So how much is kg is given here? 10 grams. So 10 gram is how much? 10, convert this 10 gram into kgs, 10 to the power minus 2 kg, correct? Centimeter is given how much? 10 centimeter. We have to convert it into meter. So 10 to the power minus 1 meter. And time, seconds. So we don't have to worry about here. So we will simply write it as 10 to the power minus 1 second. Let me repeat again. Kg meter per second square. That's our unit for force, right? And Newton. 1 Newton is 1 kg mass given how much acceleration? 1 meter per second square acceleration, right? So kg converted into 10 grams. So that will be 10 to the power minus 2 kg. Length meter is converted 10 centimeter. 10 centimeter is 0.1. Okay. So that is 10 to the power minus 1 meter, and 0.1 second is straight away 10 to the power minus 1. So when you multiply all of them, this will be how much? 10 to the power minus 2, minus 3, minus 1. Okay. So this will be, and this is whole square, second square, no? So that should be divided, not into. This should be divided. So this will be 10 to the power how much? Minus 3 divided by 10 to the power minus 2. So we left with how much? 10 to the power minus 1. And 10 to the power minus 1 is 0.1. So that will be our new unit. Okay. So the new unit of force in this system will be this. The dimensions m, l, t minus 2, a minus 2 belongs to which one of them? So first of all, first is given as magnetic flux. We know that the magnetic flux is given by phi, which is equals to B into A, magnetic field into area. And what will be the dimensions? The dimensions of magnetic flux is m, l2, t minus 2, a minus 1. Okay. So is it similar? No. So this is not correct. Let's go for option B, self-inductance. So self-inductance, okay, or self-induction, you can say, that has a dimensions which is equals to m, l2, t minus 2, a minus 2. Is it equivalent to that? Yes. So correct answer is option B. Meanwhile, let me write it for magnetic permeability also, mu naught. Okay. So mu naught is nothing but our m, l, t minus 2, a minus 2. Is it similar? Wait a minute. We have done a small mistake. L2 is not there. So this is for mu naught. Magnetic permeability has a dimensions of mlt minus 2, a minus 2. Correct? D. Option D is m permittivity. Permittivity is epsilon naught, and that is equals to m minus 1, L minus 1, T4 and E2. Okay. So the correct answer here is mu naught, which is magnetic permeability. Be very careful. L2 is there for inductance and L2 here is not given. So correct answer is mu naught. If force F, acceleration A and time t are chosen as the fundamental physical quantities, then find the dimension of energy. So we can say energy E will be equals to force dimension whole power A, acceleration A whole raised to B, and time t whole raised to C. Write the dimension of energy on the left hand side. M1, L2, T minus 2. Write the dimension of force on the right hand side. M1, L1, T minus 2 whole raised to A. Write the dimension of acceleration. L1, T minus 2 whole raised to B. And T whole raised to C. So this will be giving us MA, LA, T to the power minus 2A. Here LB, T to the power minus 2B. And T whole raised to C. Let's simplify it further. M raised to A, L raised to A plus B, T raised to minus 2A, minus 2B, and plus C. Correct? Now what we will do? We will equate it on the left hand side, which is M1 L2 T minus 2. So equating, A will be equal to 1, A plus B equals to 2, and minus 2 equals to minus 2A minus 2B plus C. So if A is 1, let's substitute here, B will be equals to 1. And if A and B are 1, let's substitute in the last equation, minus 2 and minus 2 minus 2 plus C. So C will be equal to plus 2. Correct? Let's substitute these values back to our actual equation. So E will be equals to, in terms of force, F to the power A, which is 1, A acceleration to the power B, which is 1, and T to the power C, which is 2. So F A T to the power 2, which is option B. If E and G respectively denote energy and gravitational constant, then E by G has the dimension of which one of the following, right? So E is what? Energy. So write the energy dimensions, which is M1 L2 T minus 2. And what is the dimension for G? Let's figure it out. So first of all, we know that F equals to G M1 M2 upon R square, right? This is which law? Newton's law of gravitation. So G will be nothing but Newton meter square per kg square. So how you got this? Take everything on the other side. Newton force unit, meter square R, and this 2 will kg square, which will go down. So what will be the dimension of Newton? M1 L1 T minus 2 meter square L2, and dimension of kg M2. Let's take M2 on the top. M to the power minus 1, L to the power 3, T to the power minus 2. Let's substitute it over here. So M minus 1, L3, and T minus 2. Correct? Now, let's put it in form of E by G. So E by G will be equals to M1 L2 T minus 2 whole divided by M minus 1 L3 and T minus 2. So this will give us M cancels, no, M to the power 2, L to the power minus 1, and T cancels, so T0. So M2 L minus 1 T0, which is option A. Question says dimensions of stress are, now stress is nothing but force upon area. So what's the dimension of force? M1 L1 T minus 2, and unit for dimensions for area is L2. So this will give us M1 L minus 1 T minus 2. So this will be option C. Planck's constant h, speed of light in vacuum C, and Newton's gravitational constant G are three fundamental constants. Correct? Which of the following combination of these has the dimensions of the length? Right? So we have to find the dimensions of length. So L will be proportional to h to the power A, C to the power B, and G to the power C. Correct? And we have to figure out this value of ABC. So first of all, h to the power A. First, let's write the dimensions of h, C, and G. So Planck's constant h, we can find its dimensions, and that is our E energy. E is equals to h nu, right? Okay. And nu is, when it goes on the left hand side, it will be E by nu, and 1 by nu is T. So T is joule into second. So energy joules second is the unit for H, correct? And joule is M1 L2 T minus 2. This is the dimensions of that, and into time T to the power 1. So H will has a dimension of, let me write straight away here only, dimension M1 L2 T minus 1 whole raised to A. C, speed of light L1 T minus 1 whole raised to B. And G, acceleration, no, not acceleration, Newton's gravitational constant it is. So from Newton's law of gravitation, G m1 m2 by r square, correct? And G will be Newton meter square per kg square. Newton is nothing but m1 L1 T minus 2 meter square L square upon kg square m square. So dimensions for G is nothing but m minus 1 L3 and T to the power minus 2, correct? Whole raised to C. And these three should product to give us the value of length. So this will be L, and here on simplification this will be m raised to A, L raised to 2A, T raised to minus A. This will be L raised to B, T raised to minus B, and m raised to minus C, L raised to 3C, and T raised to minus 2C. Let's simplify further. M raised to A minus C, L raised to 2A plus B plus 3C, and T raised to minus A minus B minus 2C equal to L1. So A minus C equal to 0 on equating. 2A plus B plus 3C will be equals to 1, and minus A minus B minus 2C will be equal to again 0. A minus C is 0, which means A will be equal to C. Now let's substitute this A equal to C in the remaining two equations. So this will be equals to uh, 2A, and this I am putting as 3C, so 3A. So 5A plus B equal to 1, and putting here A as C, this or C as A, it will be minus 3A minus B equal to 0. Let's add both of them. This will cancel out. 5 minus 3, 2A equal to 1. So A equal to C equal to half. If A and C equal to half, let's re-put it in the equation and simplify. B will be minus 3 by 2. Let's put all these values here, and our L will be proportional to H raised to half, C raised to half, oh sorry, not C, yeah, C raised to B it is. So C raised to minus 3 by 2, and G raised to C. G raised to C means half. So this will be, you can say L is proportional to root under HG and whole divided by C raised to 3 by 2, which is option A. Question says a physical quantity of the dimensions of length that can be formed out of C, G, and E square by 4 pi epsilon naught, where C is the velocity of light, G is the universal constant of gravitation, E is the charge, and epsilon naught is the permittivity of free space. So you have to figure out the dimensions in each one of them, and you have to see which one is corresponding to our length. Correct? So first of all, let's figure out the dimensions of these quantities. Which quantities? C, G, E square by 4 pi epsilon naught, and only these three. Yeah. So C will be, C has a dimension of speed it is, right? Velocity of light. So L1 T minus 1, correct? G, gravitational constant. Now, how do you calculate gravitational constant? F is equals to G m1 m2 upon r square, right? This is what our Newton's universal law of gravitation. So G will be having a unit of Newton meter square per kg square. If you cross multiply r square on the left hand side, it will go on the top and multiply with the force. So force as a unit of Newton meter square, and m1 m2 kg square down, right? Now what will be the dimensions of Newton? M1 L1 t minus 2 meter square L2 dimensions of kg square m2. So G will have a dimensions of m to the power minus 1, L to the power 3 and T to the power minus 2. Correct? So let me remove this whole thing. Okay. Next third quantity is E square by 4 pi epsilon naught. Correct? Now we know that our Coulomb's law F equals to 1 by 4 pi epsilon naught, okay, into Q1 Q2, and E square by 4 pi epsilon naught is nothing but n into R square, right? So if I take R square on the left hand side, that will be the dimensions for E square by 4 pi epsilon naught, right? So what is our F? M1 L1 T minus 2 and R square L2. So dimensions for E square is E square by 4 pi epsilon naught is M1 L3 T to the power minus 2. Correct? Now these are the dimensions of all of these C, G and the third quantity E square by 4 pi epsilon naught. But we want the dimensions of length out of these three. Means they should cancel out in such a way that we have to put them in all four of them and we have to check. So let's put it in the first part. So first one, 1 upon c square. 1 upon c square is 1 by L1 t to the power minus 1 whole square. Correct? Into G. G is how much? M minus 1 L3 t minus 2 into E square by 4 pi epsilon naught. M1 L3 t to the power minus 2 whole power half. Half means root. So this will be 1 by L to t minus 2. Correct? And here it will be how much? Let me make it M2 L6 t minus 4 whole power half. So root will be making it how much? M1 L3 t to the power minus 2 whole divided by L2 t to the power minus 2. And M is 1 here and here minus 1. So it won't be 2. It will be 0 here and 0 here. Correct? So now this will cancel out. T to the power minus 2 cancels and you left with L. L is the dimensions of length. So correct answer is option A.